The next series of slides will be discussing the statistics portion of the summer packet. For the next set of questions, we're going to be looking for the median and the mean for each data set. The first thing we want to do is we want to put the set in order. Now, as we notice for number 2 here, 7, 7.5, 8.5, 6.5, 7.5, 10.5, this set is not in order, so I'm going to go ahead and list them from least to greatest. After I've put everything in order, right, I've counted this up in terms of how many items there are, and there are 10, so lowercase n equals 10, that's the number of items. So there's 10 items here, and if there's 10 items, the median is going to be the average of the two in the middle. So if we number these from 1 through 10, we could see that you would have 4 items on the bottom, right? 4 items up at the top. So items 5 and 6 would be the two middle items. That's 8 plus 8.5. We're going to add that together and divide by 2. That's 16.5 divided by 2. Half of 16 is 8, and half of 0.5 is 0.25. So this would be our median, right? That's the middle set of the data. The mean is going to be the average of all of these numbers divided by 10. So we're going to add, right, all of those values from 6.5 all the way down to 10.5. So 6.5 plus 7, 7.5 twice, 8, yada, 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 all the way to 10.5. And we're going to get that value, and we're going to divide that by 10, and that's going to give us our average. And by the way, I changed this word to median. The median is the average of those two numbers. I mistakenly wrote the word average, though, which the average is also referred to as the mean, right? So average is the everyday sort of word, mean is the technical word for it. And so when I add up all of these values in the top, I get 83.5. 83.5 divided by 10 is going to give me 8.35, which is my mean. So the median is 8.25, and the mean is 8.35. Let's try that again for our number 4 example. This example has to do with per capita income, right? So that's income sort of per head, per capita, per person. And so we're going to take all of these values and we are going to put those in order first. All right, now that I have these all in order, let's keep in mind that the median is going to be, right, it's an even numbered data set. The median is going to be the average of the two values in the middle. So that's going to be the average of 17,200 and 17,615. And so when I add 17,200 to 17,615 and then take that average, right, I'm going to add that first. So that's sort of an implied parentheses. And I divide that by 2, I get $17,407.50. So that's the median. How about the mean? Now again, the mean is going to be the average of all 10 values, right? All the way to the highest value, 9790. And then I'm going to divide that by 10. And that gives us a value of $28,566.90. Now, this is the interesting thing, just on a side note. In real life, right, when we're looking at per capita income, right, we're talking about what's the typical person make, in these parts, or, what's going on. And so you look at all these values are all over the place, right? They go from as little as just under 3,000 all the way up to 90,000. And so the median is always a very fair number of what the sort of person in the middle makes, right? Which is 17,407. But when you take the arithmetic average or the mean, it shoots up to almost 30,000. So it sort of grossly overestimates what's typical here. And that's politics for you. So our last thing we have here is this dot plot. So when we look at the values across the bottom, these are obviously going up by 1. So that's 2, 3, 4, 5, 6, so on and so forth. And as I look at the value of 6, there's 2 dots there, which means the value of 6 happens twice. So there's 1, 2, 3 3s, 1 4, 3 5s, 2 6s, so on and so forth. So let's list that out. Okay, so I counted the dots and there was 22 of them. So n gives us 22. So half of 22 would be 11. So the 11th and 12th positions are what we're going to be our median. So the median is equal to the 11th plus the 12th positions divided by 2. So let's go number them and see who that is. So we have the value of 7 and 7. So our median is going to be 7 plus 7 divided by 2, which is 14 over 2, which is 7. So that's our median. Our average, of course, is adding all of the values up and dividing by 22. So the mean, right, or our average is all of the values, right, the total of all the values divided by 22. Now, just to double back for a second here, one of the reasons I know that it is the 11th and 12th position to average for the median is if I count below the 11th, there's 10 values here. If I count above the 12th, there's 10 values here. So there's the same amount of values above and below. If it were an odd number of data set, right? So say you had 5 things, right? So if I had 1, 2, 3, 4, 5, then the median would simply be the third position. There's 2 things above it and there's 2 things below it, or above and below, right? There's 10 above and there are 10 below. So again, same amount. That's how I know that I need to average the 2 centers. Back to the mean, right? I know that the total of all of these values adds up to be 138, and there's 22 items there. So I'm going to divide by 22. I'm going to get 6.27. So that is our mean. Now notice that the mean and the median are pretty close in value. That means that what's typical can be described, fairly accurately by both the mean and the median. Although the median is always a good number to use. This is the number of goals in a hockey game. So out of, say, a team plays a number of hockey games, 22 hockey games in a season. What's the typical amount of goals per game? 7. And there you go. So this last page, I'm just going to help you with how to read the charts. I'm not going to actually do the math for the mean and the median. Now we have a value of 1 right here, and then a value of 2, and a value of 3 and 4. How many times does 1 happen? 5 times. So 1 happens 5 times. 2 happens 5 times. 3 happens 7 times. So there's 7 3s, right? There's 5 1s. So that would be 1, 1, 1, 1, 1, right? There's 5 1s. And then there's 2, 2, 2, 2, 2. There's 5 2s and 7 3s. So I think you get the sort of speed here. So if I add 5 plus 5 plus 7 plus 4 plus 4 and all the way across, that total is going to give me the n number of things, right? And then you're going to have to figure out where the middle piece is. From there, calculate your mean and your median. So this one is a larger data set to add up. Over on number 8, it says this is the length of book titles, right? So we have the number of words, and it happens 3 times. So that's 1, 1, 1. Number of words, 2, and that happens 5 times. So it's 2, 2, 2, 2, and 2. So on and so forth until you get an n of, right? If you want to know what n is the total of all of those values. So 5 and 3 is 8. 9, 12, and 17. So I guess n is equal to 17 for this value. Or not value, but for this length of book titles. There's apparently 17 book titles. So there's 17 values over here. So that would mean that the middle position is going to be the 9th position is going to be equal to your median, right? Because if there's 8 below and 8 above, that's 16 plus the 9th, that's 17. Whereas 76, half of 76 is going to be 38, so the 38th and the 39th position, average that, divided by 2, that's going to be your median for this one. So as you go across, this is 5, 10, right, 17, plus another 8 is going to be 25. So you keep counting over until you get to the 38th and 39th position. Most likely it's going to be inside of one of these bars, and you'll say, oh, well, then 8's the median. And for the average, you're going to have to calculate the sum total. So 5 times 1 is 5 in here, and 5 times 2 is 10 in here, and 3 times 7, there's 21 in here, and I'm going to add all of these and divide by, right, that total, divide by 76, and that's going to be your mean. Over here, you're going to have to add up the total number of 1s, 2s, 3s, 5s, and 6s, and then divide by 17, and that's your mean over there. Now going in reverse, we're just going to look, right, for number 9. it says draw a dot plot. Well, this is a multiple choice. So here's what I notice. I notice that there's some values that are used a lot. So what I'm going to do is look for some repeats. So I'm going to look at the number 80 and see how many times I see the number 80. So there's 80 there once, 80 there twice, 80 there 3 times, 4 times, 5 times, 6 times, 7 times. And now I'm going to go look for where 80 shows up 7 times. Looks like C. 1, 2, 3, 4, 5, 6, 7. That must be the one, because this is not 7, this is not 7, right? No, no, and no. So C is my choice. So I don't have to draw the whole dot plot when I'm looking for it in a lineup. I just look for a value that repeats itself a lot of times. And I noticed that 80 was the repetitious kind of number in all of these drawings. So I just decided to track that. Now, what if I had... the other thing I noticed is that 80 is a different number in all of these, but what if it was the same? Let's see, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So what if there was 5 80s here? I would have narrowed it down to D or A, and then I would have just moved to another number to see which one it wasn't. So say I would move over to, I don't know, 75 is 3 times, and 75 is 3 times. Not a good number to use. How about 84 is used never here. 84 is used once here, so maybe look at 84. If I was narrowing down between A and D, which I wasn't. Right off the bat, I knew that it was choice C. In terms of looking for the box plot, just remember this, that inside here, this is the median, this is quartile 3, and this is quartile 1. Right? So if I take all of this data and list it in order, I'm going to look for the median. And then I'm going to match that up with the line. So it looks like this is somewhere between 4 and 5. This is somewhere between 5 and 6. This is somewhere between 5 and 6. And this is, looks like dead on 5. So let's line the data up in order. All right, so there's 21 pieces of data here. There's 21 pieces of data here. So if I have 21 pieces of data, right, if I have n of 21, then that means that the 11th position is the median, right? Because that would put 10 values above it and 10 values below it. So 10 and 10 is 20, plus the 11th would be 21. So let's go figure out where that 11th position is. So it looks to be that the 11th position is a value of 5, and there was only one box plot that had that value exact, which was D. Now remember also, the tails are going to go as far as to the max or mins. So our min was 2, that checks out on D. Our max was 15, that checks out on D, so that's pretty good. And 25% of the way would be to the 6th position, which is 3, and that checks out. So on and so forth. So you can check quartile 1 and 3 and the median and your max and your mins and everything checks out. D was our choice. But really the median, since all the medians were in different spots, seemed to land me in a pretty good location. So that's it. The statistics video is a whole lot of stuff going on here. And I think out of all of the math that you learn in high school, statistics is probably the one that carries the most weight out in real life. So it is challenging, but it is the most useful. See you in the next video.